In this video we'll talk about the upgraded air-to-ground ranging system and all the implication in the avionics of the F-16. It's a bit tricky. I hope I will be clear. I'm not sure about it, so if I'm not clear, well, I hope somebody else will manage to make it clear. Right, so let's first talk about the basics. We'll use the DTOS mode to explain a little bit the new system. So DTOS mode, you know, the SPI is the HUD, and it displays the AGR page. So the AGR page has been modified to be closer to the real one, but what is the most interesting here is the new scale on the right. So this is a slant range scale. It's 10 miles because the radar is able to provide slant ranging only at a distance below 10 miles. So here and here the diamond is the actual slant range that is measures. So here it's approximately 5 miles. You can check that in the HUD. You can see here is the slant range. It's 5.3 miles. F means that it's FCR ranging, and indeed the radar is used for ranging. When the FCR is not able to provide a ranging, then the system switches to alternate sensor, backup sensor. And here the backup sensor is the one here. It's baro, or you can cycle to the radar altitude. So if I move my SPI far away, like that, I am well above 10 miles of slant range, and you can see the AGR is not able to range anymore, and the diamond turned into a squared at the top of the scale. In the HUD, the system has switched to barometric because this is the backup sensor used, and 14.2 miles. So what does that mean, using a backup sensor? That means that the system does not know anything about the elevation of the ground. So it takes as a reference the elevation of the selected steer point. Here it's 658 feet. That means that for the system, all the ground around is 658 feet. And all the calculations of the FCC, all the display in the HUD and everything, it considers that the ground is at 658. For instance, if I increase that value to 2000, that means that the intersection with my line of sight from the HUD, which is the SPI with the ground, will be sooner, because the ground will be higher if I put 2000. That means that the slant range will be lower. Look at the slant range here. It's 14.2 and it's 9.3 because the ground is higher. Now if you switch to the backup sensor for the radar altimeter, so right now it's XXX because the radar is off. Turn it on. Okay, and now the symbology has changed. So it's R for radar altimeter, and the system will consider the ground to be the one that it's reading on his radar altimeter. And by difference between the altitude of the aircraft that is coming from the INS, GPS or barometric, it subtracts the altitude, the altitude from the radar altimeter, and as per deduction, it finds the ground elevation. So for him, all the ground elevation is at the same elevation at this point, and you can see that the value is different than barometric. Yeah, slightly different. Because the the ground is actually, I am in a quite flat area, so the radar is correct as well, the radar altimeter. But if you're flying in a in a region that is not flat, it will be much different. Or if you have a steer point that you know is not at all at the altitude of the point you want to get the slant range, then and you estimate that this point is more or less the same altitude than the ground below you, then you can use the radar altimeter, because it will be more precise. Right. So for DTOS it's quite clear. The same system is used for CCRP, and the slant range in the CCRP is actually the slant range from the bomb impact point, which means that at the moment its AGR is ranging it at 1.8 miles. It's basically the slant range of your impact. So if you go faster, it will be a little bit longer. If you pitch up and you loft, it will be higher. Now be careful, because the air-ground ranging system is limiting to something about 45 degrees pitch altitude. So if you go over, it will switch to barometric sensor. But now let's enter into Ccrp, because this is where it's interesting. Ccrp uses by default the backup sensor. So right now it's using a barometric sensor, right? And if I put my cursor just above the buildings here, okay, you can see that it's not very accurate. How it works? Basically, the XY position is accurate, but for now the radar it doesn't know the ground elevation. So as we are in Barrow, it uses the 655 feet, and so it you have the impression that it is far away than the building, but it's not far away. It's a perspective issue. It's at the correct XY position, but it's position above, because the ground is not exactly 655. For instance, if we put 800 and I put back my cursor on the building, you see it's higher. If I put 200, you see it's at the correct position now. So what does it mean? It means that unless you know perfectly what is the altitude of the target you want to attack, you cannot attack it with the Ccrp without a radar lock, because everything from of course the cues in the HUD, but more importantly the FCC calculation and the release point will be based on an altitude that will be the altitude of the steer point. So unless you have a precision steer point, or unless you enter in the elevation, the real elevation of the target, because you have a good recall or you have a 9-line, it will be wrong, and you cannot hit the target if you don't have a good elevation. So what happens here, if I put back like 1500, sorry, so you can see at 1500 the Q is much higher. You have the impression that it's far away, but it's just a perspective issue. So if you lock the target, then the radar is ranging, and it will position the SPI, the square, at the correct position. Voila. TMS up. TMS up. Now it has a good range, and it is repositioned correctly. If I go TMS down, back to Barrow. You can use the air alt as well, and it's not that bad, because we are close from the target and it's relatively flat here, but it's not accurate enough for a correct bombing run. What you can use though is using an alternate sensor that has priority above the backup sensors. This is the case of the TGP, for instance. If you go on the TGP and you use the TGP, it will be used as a sensor for ranging. What you need to do is TMS up. Okay, it's a point here, but it's no need to point. It's in tracking mode area. It's ranging, and as you can see, as it's ranging, the position here is accurate, and so you can use your TGP like that, and then you can do a CCRP run with a correct positioning. Okay, the diamond here is the position of the SPI using the barrow, and this one is using the TGP. You can also, if you are in nav mode, there are other ways to access. For example, in the weapon page, you can change the backup sensor, and all the pages have been updated, so you can change it from there. That's pretty much about it. So now it's very important to know exactly what you're doing with your sensors, and to have a perfect knowledge of the elevation that is used in order to hit the targets.